Hi guys. I actually forgot to press record when we were going over lesson 8.1, the notes for it. So that's what this is going to be. This is going to be lesson 8.1, similar shapes and scale drawings. I know there were some of you who missed it for various reasons, being online or perhaps not. So what we need to understand about similar, or maybe you just want the review, similar shapes and scale drawings is we have two things going on. So when I say that something is similar, what I mean, we're working on geometry now. And geometry is a lot of definitions and a lot of applying definitions. It always has been, it always will be. So similar is two shapes that are the same, just different sizes. All right. And scale is what I multiplied or divided by to make the new shape. That's all that scale is. So a scale drawing is a drawn picture, a drawn 2D model of a larger or smaller object. So when we are talking about scale, we have a couple of different things going on. So scale is in the form of a ratio. It always is. So that means that our scale will end up being something like 1 inch to 5 feet. So that means literally that every 1 inch equals 5 feet in real life. Sorry, I need to change that. Every 1 inch in the drawing equals 5 feet in real life. Okay, let me put in my periods for inch and foot, because then it just looks like in. Every 1 inch in the drawing equals 5 feet in real life. Okay, so that's what we're talking about when we are doing scale. Now, I will remind you, ratios can actually be written in 3 forms. The first form, here, let me go up here. I'm going to put it over here on the side. First form is, let's go 2 to 3. That's the one that I just had. However, I could also write this as 2 to 3. Or I could write it as 2 over 3 as a fraction. Just like that. All of these are exactly the same. This is 2 to 3, 2 to 3, 2 to 3. All of them. This is the one that we're actually going to end up using for the most part is going to be this one. Okay, let me undo that one. And in a much thicker one. The one we're actually going to be using mostly is the fraction one, because that one is the most useful to us. So when I have finding the actual size of something that is drawn to scale. You got some choices here. First choice is use equivalent fractions. Second choice is cross multiply. So in order to do either one of those, we have to first know what our fractions are. So I'm going to put this over here in green, I guess. Green? Yeah, let's go with green. So our fractions are going to be on the top is the drawing number compared to the actual number. Now that has to do with how much. So in this one right here, where it says 1 inch to 5 feet, the drawing number is a 1 inch actually, and the actual number is 5 feet. So 1 to 5. So I would put a 1 here, I would put a 5 here. Okay, over, oh, sorry, no, that's not what I wanted at all, is it? No, I messed myself up. Sorry. It's not drawing number to actual number. It is drawing number to drawing ratio number. Over the actual number and the actual ratio number. Sorry, I got these confused. In actuality, if I had ended up accidentally leaving it that way, it wouldn't have made a huge difference. It's just, it's easier for us to think about it this way than that way. And I'm going to put my equal sign in between. Okay. So your drawing number over your actual number is equal to the drawing ratio number over the actual ratio number. See how it goes drawing to drawing, actual to actual? So let's say that I have a shape. Let me go ahead and make up a shape, just a sec. All right, so looking at this, I have a rectangle. The short side of it is 3 inches. The long side of it is 6 inches. This is my drawing. Yes, I realize it's not actually 3 inches and 6 inches, but we're just pretending, okay? So I'm going to say that this is the drawing of a room. Okay, it's the drawing of a room. And pretty big room, actually, because every 1 inch is actually equal to 10 feet. So 1 inch to 10 feet. This is our scale down here. That's our scale. So these are the drawing measurements, and this is the scale. Actually, you know what? Let me put in the things. So in pink, sure. And then this one, undo that last one. Okay, so this is our drawing numbers. And this right here is our scale. Okay, so drawing ratio number to the actual ratio number. This is our scale. These are our drawing numbers. So let's go over here and let's solve for this. Let's figure out how big this room actually is. So I am going to first off do my drawing number of the top. I'm going to do the top first. So my drawing number is 3 inches. My drawing ratio number is 1 inch. Over my actual number, well, I don't know that yet. So that's just an X. Over my actual ratio number, which is a 10 feet. Let me see if this will actually let me just put it up larger. There we go. Okay, let me add in my lines and my equal sign. There we go. Okay, so now your choice is, you can either say, what did I do to this to make this? So what did I do to the 1 to make it a 3? That one's really straightforward. I multiplied by 3. I went times 3. So on the bottom, whatever I do to the top, I have to do to the bottom. So 10 times 3 is 30. So we end up with x equals 30 inches, 30 feet. So in actuality, the top, the short side of this is 30 feet long. Now I'm going to show you the long side of it, but this time I'm going to use cross multiplication. That time I was talking about so we're going, I guess technically yeah, okay, fine. We can go times 10, or it's technically divided by 10, although I always look at it as times. So whatever I do to the bottom, whatever I do to the top, I have to do to the bottom. And I guess I'm going to put in my arrows pointing the opposite direction. So it's times 10 going from here to here. Dude, why are those arrows so big? Just a sec. All right, there we go. So I multiplied times 10 going in. Oh, sorry. Times, dude, why did I put down times 10? It's not times 10, it's times 3. Oh my word. Oh my goodness. Okay, so I times by 3 going in that direction. Times 3 on the top and times 3 on the bottom. Yeesh. So the 1 times 3 gave us a 3. The 10 times 3 gave us a 30. So x is equal to 30. Let's set up our second problem. I'm going to do this one in blue. So our second one, we start out exactly the same way. Our drawing number, which is 6 inches, set equal to our ratio, our drawing ratio number, which is 1 inch, over our actual number, which we do not know, and the actual ratio number, which is 10 feet. Let me change the size of these. And let me put in all of my other things that I need to put in before we can actually solve this problem. So all the lines and all that jazz. All right. So this time we are going to do it by cross multiplication instead. I'm going to show you how to do it this way. I need my circles. I need this color. Let's see, are you going to let me? Oh, no, you're not going to let me do it. Okay, never mind. I'm going to just draw it then. So cross multiplication, we go this way. And we go this way. And so I am literally left with the 1 times the x equals the 6 times the 10. Which becomes x equals 6 times 10 is 60, 60 feet. So our long side will be 60 feet, and the entire room is 30 feet by 60 feet. Okay? You with me so far? This is all that we're doing with this. The more numbers that they give you every single time you do this, the ratio, the scale never changes. The only thing that changes is they give you the drawing number or they give you the actual number. Now, this entire one, both of these were, I already had the drawing and I needed to find out how big it actually was. Okay, that was both of these. You can do it the other way too. I can tell you what the actual thing is that you're supposed to be drawing, and you can use exactly the same equation to figure out what the what size your shape should be in your drawing, how large you should make your drawing. Okay, so we're going to do a what if scenario here. I know that this is actually a perfect diamond, and as such, all of these are exactly the same length. I'm pretending that it's a kite, though. So the top two are the same length and the bottom two are the same length. I gave them different lengths so we would have two sets of numbers to work with, because otherwise we would only have one set of numbers to work with. I also put my scale down here at the bottom. You will notice that scale is almost always at the bottom, okay? So we are also pretending, in addition to pretending that this is not a perfect diamond, but rather a kite, we are also pretending that this is the actual object. This is the actual thing that we are looking at, that it is actually, the object that we're looking at is 30 yards by 40 yards, and that we need to make a drawing of it that is 2 centimeters for every 5 yards. So we have the actual size. Right now we're looking for what our drawing size is for it. So let me put our equation up again. Here is our equation for it. The drawing number over the actual number is equal to the drawing ratio number over the actual ratio number. So in order to solve this, we're going to do the 30 first. I do not know the drawing number. However, I do know the actual number. And I also know the drawing ratio number and the actual ratio number. So I can put in all of that information. The drawing number, I don't know. The actual number is 30. The drawing ratio number is 2 centimeters. The actual ratio number is 5 yards. You will notice yard to yard, centimeter to centimeter. That's how you can check to make sure that you actually have your information in the right slots. For this particular one, we are going to do the equivalent fraction method. So the question is, what did I do to 5 to make it a 30? Whatever I did to 5 to make it a 30, I will also do to 2 to figure out what x is. I multiplied by 6. 5 times 6 is 30. So 2 times 6 is 12. Next one. I have x over 40 because I do not know what the drawing number is. And 40 is how much the actual number is. And our drawing ratio over our actual ratio. So 2 centimeters over 5 yards. Yards, yards, centimeters, centimeters. This one I am actually going to do cross multiplication with. So I will multiply those. I will multiply those. And when I write it out, I have 40 times 2, which is equal to 5x, because the 40 times 2 and then the 5 times x. 40 times 2 is 80, which is equal to 5x. I then divide by 5 on both sides. That cancels out that one set of 5s. So now I'm left with 80 divided by 5, which is 16. So x is equal to 16 centimeters. Okay, just a second. I think that might be everything that we need on here. Okay, so one last thing to talk about. Oh, just a second. This bar that you see up here is what is typically put onto maps when you're looking at them and you need to figure out how far the distance is from one place to another. The way that we read this is 1 inch is equal to 6 miles. So if you had your ruler, you could then take the 1 inch and you measure out to 6 miles. They will also normally, and I forgot to put this in here, they will normally have a 1 inch 6 miles thing over off to the side as well. They normally have it actually written as well as just in the picture drawing. So if I had on my map, I had a place that was, let's say that I had a place that was 5 inches away from another place, I would do my equation, 5 inches, and then 1 inch. I don't know what X is, but I do know that that is going to be 6 miles. I go in here, I put in my equal sign, I put in my lines. And I can then sit here and cross multiply, or I can go over and I can do my equivalent fractions. Or I can just look up here at my key and go, oh, okay, so it was 5 inches. That means that X is 30 miles. All right, I can do all of those. I'm not going to go over inside the book. The homework, however, is you can look inside it's supposed to be self-explanatory going through the book. The homework is page 240 to 241, numbers 1 to 3, and number 7. Okay, numbers 1 to 3 and number 7. And that's posted over in our classroom in case you forget what it is. So I will talk to you guys later. Bye.